Welcome to 2.4, Ins and Outs of Polygons. Okay, let's go ahead and get started. The first thing I wanted to talk about today are a couple of your vocabulary words, specifically convex and concave. Now you'll see these in science, you'll see these words in math as well. And with our angles or polygons, you will find convex polygons and concave polygons. They are not regular polygons because they are convex and concave. Now, what makes the difference between a convex polygon and a concave polygon? So as you can see here, all of the interior angles must be less than 180 degrees for something to be convex, okay? So all of them have to be that way, all right? So all of the interior angles here have to be less than 180 degrees. Now, as we look at it as a star, it's kind of convex, but it can also be concave depending on how you look at it. Convex meaning more that it's sticking out, concave meaning more that it sticks in, okay? This is a much better example of concave in that at least one interior angle must measure more than 80 degrees. So we have one interior angle here that measures more than 180 degrees because, as you remember right, 180 degrees would be a straight line. Okay, so this is more than 180 degrees. So we can say that this shape is concave. All right, moving on. The next thing I wanted to talk about is just to reinforce the difference between an exterior angle and an interior angle, okay? So interior obviously is in the inside, and the exterior is on the outside. Now, one really important point that I want to make here is that when you take your exterior angle, okay, and you add it to your interior angle, you make 180 degrees, okay? If I have an angle that equals 180 degrees, I have a supplementary angle, okay? So, supplementary angles, as we just said, equal 180 degrees. Each exterior and its adjacent, so that one that's right next to it, just as this figure up in here, you add those two together and you have supplementary angles. So if I were trying, for instance, to figure out what this angle was, all I have to do is, if I know the degrees of this angle here, then all I have to do is subtract this angle from 180, and then that would give me my interior angle here, and we'll call that one Y. Okay, so just to start out, this angle here I measured ahead of time is 55 degrees. So X equals 55. If I know that X equals 55, all I've got to do here is take 180, subtract 155, and that will give me my Y. So basically what I'm saying is X, angle X, plus angle Y will equal 180 degrees. So when you're looking at a shape like this, look for those straight lines. So when you're looking at polygons and you're trying to figure out their interior or their exterior angles, look for these straight lines. This angle plus this angle will equal 180 degrees. Okay, so let's go back to our problem that we had here. So we have angle X, which equals 55 degrees. We have, and we're trying to figure out the interior angle or angle Y. So to do this, all we have to do is 180 minus 55, and that gives us, so angle Y right here equals 125 degrees. So I know we've talked about all of these things before, but I really want to make sure that while you're looking at your problems, that you're looking for clues that will help you. All right, so one of the clues, like I said before, is look for these straight lines, and then you'll be reminded, aha, I've got supplementary angles, they will equal 180 degrees. Remember, on the outside, they're exterior, on the inside, they're interior. And remember, when something is concave, you have to have at least one angle measuring greater than 80 degrees. And if something is convex, all of the interior angles must measure less than 180 degrees. Okay, I think we got it. Good luck on 2.4, the ins and outs of angles. I know you can.